Good morning, everybody. Can you hear me? Brilliant. Now, when we did the tech check half an hour ago, there was an adapter here. There isn't anymore. They're on it. So you might get to listen to me ad-lib for a few minutes. Who knows what Matrix is? Okay, an alarming number of people do. Thank you for using Matrix, if you're using it already. Apologies if you've hit any bumps along the way, particularly as we went on our mission through to Matrix 1.0 this year. What I'm going to talk about in this talk is really how we got to where we were with 1.0 and what's coming up on the horizon. We've actually got a lot of material to work through, so apologies in advance for talking fast. Also, if anybody has any questions along the way, just like yell or something, don't bother with the Slido thing, just go and heckle, and I'll try to answer them as we go. Okay, we've got video. Everybody sitting comfortably-ish. Brilliant, I'll begin. So first of all, Matrix, if you don't know what it is an open network for secure, decentralized real-time communications. You use it for chat, VoIP. You can use it for open communication in VR and AR. You could use it as an IoT data fabric. In the end, it's just a big network of JSON where you can replicate JSON between a decentralized, open network of servers. Our mission is to create a global encrypted comms network that basically replaces the phone network and replaces email. Nowadays, we are all grown up with our 1.0. We've got a software foundation properly set up. We even have a manifesto. And the four main bullets from the manifesto is that we think that people should be able to fully control their own comms. They shouldn't be locked into centralized silos, and they should pick who they host their communication with. They should be able to converse securely and privately as a basic human right. And it's interesting, actually, if you check the UN Bill of Universal Declaration of Human Rights, there is an item for communication, but not private communication. And we quite seriously want to fix that. And finally, communication itself should be available to everybody for free as in Libre and open, unencumbered standard and a global network. So in practice, it looks kind of like this, or not like this. Matrix is the big hole in the middle. You have all of these centralized silos today, Slack, Discord, Telegram, Wire, whatever it might happen to be. And Matrix can be a big glue to link them together. The servers themselves are decentralized, and we have a thin client protocol where little clients talk a very, very simple HTTP API across through to the nodes which are participating in the network itself. The whole point is that no single centralized party should ever own your conversations. The conversations are replicated in a Merkle DAG on the servers over all of the participating servers. So in detail, you have a full mesh of servers participating in a conversation. You have the little clients hanging off it. You have application servers, which bridge through to other technologies like Slack or whatever. And we also have the concept of identity servers, which are simply phone books. They go and map your phone number or your email address through to an identifier within the Matrix network, so you can discover who else is on the network and how to talk to them. So what do you get? Well, conversation history, really important to note, Matrix is not a message passing system. You are synchronizing conversation history between chat rooms. That means you get group messaging for free, end-to-end encryption using Ohm and MegOhm, the double ratchet algorithm and the extension of it that we built is there as a first-class citizen, very soon to be turned on by default. In fact, we have the Matrix spec change proposal out there now in order to get E2E on by default for DMs at last. Nowadays, you get editable messages, reactions, VoIP calling over WebRTC, which is a little bit flaky, but we're going to be working on that real soon now. Server-side push notification and search, read receipts, typing notice, all the good stuff that you'd expect from a Slack or WhatsApp kind of experience, except it's all open source and open standards-based and decentralized. So the ecosystem as it stands today looks a bit like this. The spec here is the main deliverable that we provide as the foundation, which is one great big monolithic document that defines all of the APIs that the clients up top here use to talk through to the servers down here. We provide a Python implementation called Synapse, which is pretty mature now, and it used to be a bit flaky and a bit of a resource hog, but is getting better and better, especially since it hit 1.0 in June. We have our next-gen Golang implementation called Dendrite, which is becoming increasingly, how shall I say, domain-specific, and I'll talk about that a bit later. You've got lots of bridges through to other systems, and then the purple boxes are ones implemented by the community. And there are a bunch of servers out there. There are loads of bridges and bots and integrations to other systems. And on the client side, we provide a JavaScript stack, an iOS stack, and nowadays 2 Android stacks, the old crappy legacy Java one and the new shiny Kotlin Jetpack one as well as lots and lots of clients written by the community. WeChat Matrix is a lovely command line one if you want to geek out on a command line interface using a Python plugin for WeChat, which even does all of the end-to-end encryption. It's really, really cute. Thunderbird is working on implementing Matrix alongside email, which would be pretty cool. I think that's due for Thunderbird 76 or something. You've got native clients for macOS, lots and lots out there. Basically, the idea is that writing a client should be dead easy. It's a single HTTP hit to send a message, single HTTP hit to receive a message. And that's all you need to know. Even with the end-to-end encryption stuff, we now have a project called Pantalaimon. If you know the Philip Pullman books and his Dark Materials, the name might make some sense. And Pantalaimon is a daemon which offloads the E2E for you. So rather than talking plain old curl or whatever from your client through to the server, you instead route it to Pantalaimon that encrypts it and then sends it on for you. What else can I tell you about Matrix as a whole? Yes, servers are hard, clients are easy. At the moment, we use HTTP between the clients and the servers, and the servers and the servers, but we're getting a lot, we're experimenting a lot more at the moment with better things than HTTP. So quick, brief history. We're quite an old project by these standards. We got the idea in 2012 or 13, got the first, actually started building it in May 2014, shipped in September, which was barely usable. 2015 was kind of make it work. 2016 was make it scale enough and get E2E out there. 2017 was a little bit of a funding mess where we went on to shiny things, which often happens when you have a funding mess, like stickers and widgets and stuff like that. That thankfully got resolved. Many thanks to Status for funding us at the end of 2017, at which point we promptly went the other extreme and went into feature freeze, stability, get a 1.0 out, get out of beta, and it was all about security, stability, and governance. And then this year, we actually shipped, and now we're back into the shiny stuff again. This is what the daily active users look like on matrix.org today, since January 2016, before which it was pretty negligible. You can see that we had a bit of a slowdown in 2018 for a couple of months when we were dealing with scalability and security dramas, which happily got unblocked, and immediately things started going up again. We had another little wobble back in April. Apologies if anybody got caught in the fallout of a security issue we had on the matrix.org data center then. However, despite that, we've just hit 100,000 daily actives on the matrix.org server, and the curve is looking suitably alarming in terms of keeping scalability going. And that's why this talk is nominally about decentralized communications at scale. We've been doing this a while now, and it's only getting bigger. Couple of stats. We can see just over 10 million accounts on the network as a whole, in terms of literally, select or distinct accounts of the matrix.org server. It's a couple of million messages a day. Some of those accounts are brought in from other systems. There are people on Telegram or IRC or XMPP or Slack or whatever. The native Matrix ones are about 4.5 million currently. The matrix.org server is in over 2 million conversations. If you literally select destinations from matrix.org, you get 21,000 federated servers at the moment, but there are a lot of people who run dark out there. We reckon the real figure is more like 40, 50,000 now. On matrix.org itself, we see about 30 transactions a second coming in and about 3,000 going out, because lots of big rooms, so one message comes in and gets relayed out to lots of people. And lots and lots and lots of stuff in the community, at least 400 projects building on Matrix, to the extent that we've kind of given up trying to count them all. And in terms of companies building on top, God knows. I mean, a new one pops up every couple of days at the moment because so many people do it in stealth or don't even admit that they're using Matrix. So 1.0 itself, we exited beta in June, all about security correctness and spec completeness. I mean, the whole model of Matrix is to make it work right, and then make it fast. So we made it work a long time ago. Making it work right was a bit more of an effort, and now we're finally shifting into the make it fast phase post 1.0. Some of the stuff that went into the 1.0 release was an entirely new merge resolution algorithm, because this is the academically hardest bit of Matrix, that if you replicate your room over all these different servers, it is eventually consistent. It's not a blockchain, there isn't a sealing mechanism on it. It's a feature if one of the servers goes and drifts off by itself, disconnected for a few weeks, and comes back, and you need to be able to merge what happened with what happened on the other servers participating in that room. Doing that for conversations is easy. Doing it when people get kicked and banned and ops, and when you start storing key value pairs in the room, gets a lot harder. We got it wrong first time, which is why you sometimes used to see flakiness in Matrix, where people would pop back into a room because an old version of the room would be resolved with the current version of the room, and if we got the calculations wrong, the old version would sometimes win, so time would go back in time, which is not what people want. That is now resolved, and it's rolled out in new room versions. We also have collision-resistant event ID hashes and various other fairly fundamental thing codes from the original protocol. This involved implementing room versioning, or hard forks, as you might like to refer to it, which was a pain in the ass because we didn't implement them from the outset, so we had to go and put all of the version dependency stuff in there. And in the near future, if you use Matrix today, we'll see little banners popping up on the top of rooms saying, hey, this room is now insecure, please click here to upgrade it. And if you're an admin, it will basically throw away the room, replace it with a new one, hopefully invite all the old people into it. It should be basically transparent, but what's happening under the hood is that we're just throwing away the old data structure and building an entirely new one, and then stitching the two together cosmetically in the app. We also switched how we did server authentication, no longer used in perspectives, but boring old X509 certificates, unfortunately, mainly because life's too short to support a TLS or a certificate authority alternative, as well as doing the rest of Matrix. We added .well-known support, so you don't need to use DNS to discover servers anymore. We critically released the stable spec across all of Matrix at last, particularly the server-server federation API, which we've been putting off for as long as possible until we got it right. And we also, going forwards, have shifted Synapse from Python 3. Finally, thankfully, that means we can get back to the fun stuff. We also launched the Foundation. This is a UK non-profit community interest company, neutral custodian of the protocol, and it comes with the entire enchilada. If you like your governance stuff, go and look at matrix.org/foundation, and you can see our manifesto, mission, value statements, and the entire constitution, which is in fact turned into the actual articles of association of the company. So we're doing this in a centralized, or vaguely centralized governance model. It's not a DAO. Instead, we have an 8-person expert team who are basically some of the most active long-term people on the project. Many of them are paid to work full-time on Matrix by New Vector, which is the startup we set up 2 years ago to hire the core team. However, we also have 5 guardians, who are the directors, technically, of the Foundation, who are the neutral custodians to make sure that if I, wearing my New Vector hat, went evil and started saying, hey, Matrix will be proprietary and you have to pay to use E2E or some other craziness, which I'm not going to do, then the directors can step in and override and make sure that the project stays on track in accordance with the values which we've put down. And the guardians are myself, Amandine, my co-founder for Matrix. We started it together back in 2012 or whatever. We have Jutta from Imparity. Jutta, if you're in the house, thank you for being our guardian. We've got Professor John Crowcroft, who's the Marconi Professor of Communication at Cambridge University in England. And then you've got Ross, who is a tech lawyer and expert in decentralization at New America. So if you're wondering how the governance model of Matrix works these days, you basically got 8 people frantically working on the spec and 5 guardians looking over their shoulders saying, really, are we meant to be doing that way? Although I'm happy to say so far the guardians haven't had to have an intervention. France was a big deal for us this year. So the French Ministry of Digital reached out in 2018 to ask if they could use Matrix to replace Telegram and WhatsApp across the entire public sector. So that's 5.5 million users, that's 16 ministries, and at first we thought they were joking because the last people we expected wanting end-to-end encrypted decentralized communication was governments, but it turns out that, hey, governments are decentralized and they really like end-to-end encryption for themselves. and they wanted to get involved. And so we've done a lot of work with them, rolling out a massive, I think it's at 65 servers now, spread across the country in different domains, implementing mandatory E2E encryption across the whole shebang, which has been great for us to see how, if you wedge E2E on by default, how it works. Adding on stuff like enterprise-grade antivirus support, all sorts of different security zones. It starts off as a private federation, and then moves public in future, which is even more exciting, that they're not doing it as a horrible silo. They want to bridge into the open network, obviously through sufficient border gateway controllers and firewalls and things. So the app itself looks like that. I don't have time to demo it to you. It's all open source, it's Apache licensed, it's a fork of Riot, but as you can see, it doesn't look remotely like Riot. For one thing, it is red, white, and blue, as you might expect. And it started on Android, then web, then iOS. Launched it this year in April. It's going pretty well. They've got tens of thousands of users on it, although tragically traffic looks to have dropped off during August. I have no idea why. And it involved also lots and lots of Ansible, going and keeping all of these servers in different data centers, some on-premise, some in the cloud, in sync and updated. And it's been a really fun project to work on. And we've also started talking to a whole bunch of other countries who want to get on it too. This is in no way a secret plan to try to take over the world with Matrix, where we get a whole bunch of massive countries using it, and then we get NATO using it, and then, well, bye-bye phone network. Very approximately, and not remotely accurately, it looks a bit like this. You have France with a whole bunch of, what was that? With a whole bunch of different servers in it. I'm trying to ignore that, forms a pentagram. And you have bridges through to XMPP, not that they're using that yet. You've got non-government people using public-facing servers. You could bridge through to other things. And in future, you'd have a border gateway going through to the rest of Matrix. Lots of work driven by France, particularly performance. Lazy loading was a massive one, so that now we only send you the data that you need to render the client in Riot, whereas previously the first thing it would do would be to download everything on your account, or at least the last 20 messages of every room. And if you're in lots of big rooms, that meant that you got like 20,000 user profiles every time you set the app going. I think I had the record at 350,000 user profiles when I started my Riot. Nowadays I get about 8,000, which are the people I'm actually actively talking to, rather than everyone who it's ever seen. So massive improvement on bandwidth and RAM. Python 3 is a big win too, and also lots of general maintenance work, making sure that Synapse is actually good enough for public sector use. Other scaling and performance work we've done has been fixing forward extremities. If anybody has the misfortune of running a Matrix server for a while, you would have discovered the nightmare that the rooms can fragment, and it feels a bit like using DOS back in the day, and everything gets a bit slow. And the reason is that if you have increasingly bifurcated DAG in a room where people don't tend to talk very much, then every time something does happen in that room, you have to resolve this fragmented DAG and try to work out what is currently at the tip. And basically, we've put a workaround in place that finally resolves that, so to speak. When you have more than 10 extremities, it goes and puts in a dummy node in order to re-heal the DAG, which sounds like an easy solution, but turns out to be quite hard to make sure you don't have lots of servers fighting against each other trying to heal the room. We also have much better caching, which has caused massive performance improvements. We have an ongoing QoS project for federation that makes sure that if you have a crappy slow server somewhere, it doesn't bog it down for everybody else. Dendrite, the Golang one, is edging forwards, and then coming up, we've got sharding Synapse into rooms, speeding up joins at last. I apologize for how slow joins are today, but this will soon be a thing of the past. Incremental state res, so at the moment, if you do have two copies of a room and you want to resolve them together, we basically have to replay the semantic history of the room from day one, and if it's a big room, that can take ages, whereas here, instead, we can cheat and just do the bits which changed. Mathematically, it's a nightmare, but it should work. We implemented it last year, but it was on the wrong algorithm. Now we need to do it again on the right algorithm. Finally, state chunking, so if your room keeps getting split up over time, you model it in different chunks, and you only need to resolve the most recent chunks rather than considering all of it. And finally, state compression, because at the moment the scheme is a bit thick when it stores the evolution of the room on disk. This is what the perf improvements in the last couple of weeks have looked like. Things were getting pretty bad on matrix.org server itself. They were, the modal group for time taken to send a message was between 1 and 3 seconds, which is abysmal. I'm happy to say that after we put the latest state caching stuff in, the mode was shifted down to 25 to 50 milliseconds, which sounds a lot more like it. So hopefully, if you use the matrix.org server, you will have seen it getting snappy. And even if you don't, that shipped in Synapse 1.3 last week. So you should have upgraded by now anyway and have it. For other fun stuff, since 1.0, we finally have reactions and editable messages. Woohoo! Sorry it took us so long to get there, but hopefully it's worth it. RiotX, if you haven't played with it, is an entirely from scratch new client written in Kotlin using the Jetpack and the Android X stuff. It's lovely. It's about 10 times faster than Riot Android. It's about 4 times smaller in terms of APK size, and it's just a real breath of fresh air. It's not totally feature complete, but it does have E2E encryption. It doesn't have VoIP. It doesn't have, I think it has read receipts as of yesterday. So if you're a Riot Power user, please install RiotX on Android, run the two side by side, and hopefully you'll find yourself never using old Riot again. Emoji verification of E2E is a big improvement in how you verify people over E2E. I already mentioned little pantomime that turns anything into being E2E capable. That was a hard requirement for turning on E2E by default. It also acts as an E2E search engine, which is really cute. We've got Bifrost, which is a new bridge framework written specifically for X and PP, but it also supports anything libpurple can talk to, which is a really exciting glue all the things together project. Been doing a lot of work on low bandwidth matrix transports, which I will try to talk about and demo in the little time I have left. And E2E cross-signing is the single biggest thing that we've been working on the crypto side. Good news is that the spec and the code exists. And it even works. We've got test jigs that prove that it works. However, the UI on Riot needs to be implemented, and this irritatingly now has been blocked for over a month on privacy work. So on privacy, we've got some folks campaigning very, very strongly that we fix every single little last privacy issue in Matrix. Some of them are embarrassing thinkers, some of them are fairly minor, but if you care, as I'm sure many people here do, about every last detail of the privacy, it's stuff like making sure that Riot works well, even if you don't have an identity server for your phone book or an integration manager for managing your widgets in there. Ensure that if you do use them, you actually remember to do the GDPR consent flow. Sorry about that. Garbage collecting deleted data properly is a massive thing that we've almost finished. Per room data retention could be a big deal for lots of people here. Previously, your rooms grew as big as you liked until the server admin got annoyed and started dropping rows from the database. Instead, now you can configure per room how long you keep your data for and say, hey, this room should last for 5 seconds, or this room should last for 2 months, or whatever. Moves, password reset and registration, email verification to the server. Hash your contacts during contact directory discovery even. Doesn't really buy you much because of rainbow tables, but we do it anyway now. Don't fall back to Google Turn if things go wrong. Lots of various hygiene and stupid bugs. All of this will ship in the very near future. Hopefully this week, possibly next week. So what's next? Lots of things. Graphical installers, open tracing, making Riot's first-time user experience not suck. We know that there is still a long way to go for new users to get them onto Riot. We're determined to be better than Slack or Discord or Telegram in this respect. Need to redo communities so they don't suck. We've got somebody sponsoring threading work, so that should be coming fairly soon. Profiles, decentralized accounts, also getting rid of MX IDs as part of that, so you have portable accounts. Finishing RiotX, P2P Matrix, and then 2 minor little points of decentralized reputation and identity. With 10 million users, reputation is getting a big deal. There are lots of interesting people in Matrix. I want to have the ability to turn down the porn, or turn up the porn, or turn down the right-wing people, or turn down the left-wing people, or whatever it might happen to be. And we need to provide tools to let the users, nobody else, just the users at least, decide what they want to tune into. There's the Synapse installer that will be coming real soon now. So, quickly, P2P Matrix, anyone? I mean, this is a decentralization conference, and lots of people give Matrix flack for not really being decentralized because you have clients. I say that's total bullshit, if you excuse my language, because the servers are completely data structure-wise decentralized. It's like saying Git isn't decentralized. But what we do is to obviously have the thin clients talking to the servers. Now, there is no reason why we cannot run Matrix nodes on the client rather than on the server. Just 3 simple steps. Switch to using keys for identifiers rather than DNS-based MXIDs. We can take a server like Dendrite and compile it to WASM and say run it in a browser. And then we can swap out HTTP between the nodes with something like, I don't know, libp2p or some other peer-to-peer transport. You run Dendrite in a service worker, and the really lovely thing is that the client doesn't change at all. There is not a single line of code that changes in Riot. It's still talking HTTP to a server. It's just happening that the server runs on the client rather than on the server. So we've been experimenting on this. And in fact, I did a mini hackathon yesterday, hoping to pull this together to show it off today, and got as far as drawing this diagram. No, I got a bit further than this. I went and implemented the green bit here, which is you got Riot Web talking through to Dendrite and WASM, and you need something that takes its HTTP and uses the Go HTTP stack both as a client and a server, and then routes it over libp2p for peer-to-peer between the browsers using the WebRTC style signaling or the WebSocket style signaling that you get out of libp2p. I got as far as doing HTTP requests from Go through to HTTP requests here using this new RPC library, which I haven't released yet because it's pretty hacky, desperate hacking to try to pull it together. But it shows the concept can work really quite nicely. And in fact, you could take any Golang-based client or server, which is currently doing conventional Web 2.0, Web 1.0 for that matter, requests back and forward, and compile it to WASM, and then suddenly put the server in one browser and the client in another browser, and hi presto, you've gone and peer-to-peerified your boring old conventional client-server architecture, which I think is pretty cool. I suspect that IPFS people or Protocol Labs people are going, oh, they've got to put HTTP over libp2p, that's not how it's meant to work, but hey, from a pragmatic hat perspective, it's the quickest way we can go and P2P Matrix. Very quickly, I got 3 minutes. Insanely low bandwidth matrix. This stuff is really cool. Completely separate to the P2P stuff, we've got a different transport going on. Target, 100 bits a second. Takes 2 minutes to send an Ethernet packet at that speed. Why would you do this? If you're in an emergency situation or some kind of really appalling connectivity situation, you want every bit to count. You don't want to not be found by the rescue helicopter because it was doing a HTTP handshake. So we started off looking at HTTP1 with TLS. Turns out to be about 8K per request, which is horrible. HTTP2, it's a little bit better, 6.7. HTTP3 doesn't actually help us that much because quick requires bit stuffing, and so it's about 6.7K. Then we moved to CoAP, which is an IoT protocol, super, super bit efficient, at which point we're down to half a K, so only 40 seconds to send a message. Sounds pretty promising. Then CoAP and DTLS to get encryption in. However, DTLS is a bit of a pain and a bit archaic, so we went and took noise and hooked it up instead as the encryption transport using an XX and IK handshake. Sorry for going super fast here. This brings it down to about 32 bytes per token to set up, and then 16 bytes per message of AEAD tag overhead. Then we switched from JSON to CBOR, which gives us 75% smaller. Then we went and compressed that using Deflate with a custom pre-shared dictionary, at which point we get down to 90 bytes per message, including all headers, including Ethernet headers, plus 16 bytes of crypto overhead if you're not on encrypted transport, which is 8 seconds to send a message at 100 bits a second for, I think the message was hello world or something, which I think is a bit of a win. So architecturally, we've gone and taken, rather than client-server-server client talking HTTP, we run it through a coap-proxy that just turns the HTTP and squidges it from 7K of HTTP down to 10 bytes of coap. So it's a 65 times improvement in transport. So I've got 1 minute and 20 seconds left. This is the final thing in the talk. Let me see if I can very quickly demo this. So what I have here is a thing called MeshSim, which is a Docker network simulator, which coughs up a web interface that looks like this. And what it allows me to do, if I put these guys side by side, can you see that okay? Is it vaguely visible? Yeah, cool. If I start clicking here, it starts spinning up on my local laptop Docker synapses. Each one's in its own container. And I can literally go click, clicky, click, 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 like so. And it creates a mesh network of synapses together. Ta-da! It goes and automatically links together the closest 4 or 5 nodes. And I can actually drag these around. And you can see the latencies here are the real deal. So I can go and shell into one of these Dockers. Can I remember how to use Docker? That would be embarrassing, wouldn't it? Does that look vaguely plausible? Oh, it does. Cool. So I could like trace route from 0 through to Synapse 7 even. And you can see that it's going from 247, so it's going 0, 247, and you can see the latencies here on the, it's a real network with real containers routing traffic around. Now, what I can do here is to go and join a room across the network. In fact, I'll make one first, like so, and I'll get these 10, or was it 8, 9 servers to join it. And hopefully, you can start to see traffic flowing around over the networks as the various different servers go and start converging on the room. And the color here shows the most recent message that a server received. And so by this point, they're pretty much-ish, sort of, all in that room. Now, if I go and send a message today, and I'll send it from the first server, and I'll send it to all of the others. Oh, no, that's not what I meant to do. That's what happens if all the servers send a message at the same time. Let me just send it from one. OK, ooh, no, from one. There we go. So that's server 0 sending a message to the others. And let me slow things down, because this is going way too fast. And I need to change the threshold for wiring this guy together, like so. And I'm over time, so I'll wrap it up very, very quickly. This is what happens today when you send a message mesh over Matrix, and this is all going over the car transport. You can see a bunch of messages went out, fanned out across the whole network. If I remove the mesh, then we've got an entirely new routing protocol here, which, as you can see, is only 2 messages were used to go and span the entire network. And it's using a sort of spanning tree style approach, which is attempting to be Byzantine fault tolerant in order to do better than this full mesh n squared thing. I'm totally out of time, so I should wrap it up. But thank you, everybody.